Today's video starts on page 35 in your 2C packet. It's a problem of the day. The Math Journal question asks you to use diagrams to illustrate each of the following: a transversal, corresponding angles, alternate exterior angles, and alternate interior angles. Label your diagram or diagrams. Please draw at least two to label all of these. You should be using a straight edge or ruler because these are parallel lines cut by a transversal. And explain which angles are congruent. And explain which angles are congruent. So you're going to have to probably number them and say something like angle 1 is congruent to angle 7 because they're labeled as alternate exterior, etc. So I'm going to look for a couple pictures, at least two. If you want to draw three, you can use three. And then I'd like you to do this word problem. We've seen this kind of problem before with the tens digit, hint, hint, and the ones digit. So you're trying to find the original number. You're going to need two let statements, tens digit and ones digit. This hands-on activity is a great activity to try at home. Grab a sheet of paper, blank sheet of paper, draw a big triangle on it, number the angles 1, 2, and 3, cut it apart, tear it apart, and then put those angles 1, 2, and 3 next to each other, and you'll see that they fit to add to 180 degrees, which is a half circle. So you'll see that they make a straight angle when you put those three angles together, or a half circle. And the sum of the angles of the interior angles of a triangle measures to 180 degrees. You may want to turn down your volume for a minute because the board just for some reason is not calibrated, so I'm going to have to do that. Next page. Use the angle sum of a triangle to find an unknown angle measure. When we know the angles in a triangle sum to 180. In triangle PQR, QRP is 48, PQR is 31. Find the value of x. So what's the missing angle? And you can see that it's worked out here. You're going to add the two angles that you have, subtract from 180, and you get that that missing angle is 101 degrees. So let's try this question, very similar. We know that these three angles in this triangle are going to add to 180. So if we add RPQ, which is the 35 degree angle, plus the QRP, which is angle P, and then PQR, which is the 57, they should add to 180. Well, 35 and 57 adds to 92. And when I subtract 92 from both sides, so I'm going to go ahead and do that, I get that P must have to be 88 degrees. Very close to a right angle there. Next page. Using the angle sum of a triangle to find an unknown angle measure in an isosceles triangle. An isosceles triangle, the angles opposite a congruent side. So an isosceles triangle has at least two sides that are congruent. So you can see these little tick marks means that they are the same measure. The angles opposite them are also congruent. Sides and angles in triangles have very special relationships. In triangle PQR, this is an isosceles triangle where that vertex angle P, QRP, or QPR, is 40 degrees. Find the value of x. Well, I know that those two base angles, they're called, have to be exactly the same. So that 40 degree angle subtracted from the 180 gives you 140. Those two angles have to be the same. So if this is x, that's x. So dividing by 2, you can see that the base angles are both 70 degrees. Using that idea here, triangle XYZ is an isosceles triangle. You have to be told that, or they may not tell you this. They may just put these little tick marks in the sides, which means they are equal in measure. XYZ is 55 degrees, which I know if XYZ is 55 degrees, then this angle Z down here is also 55 degrees. So I'm going to write it in. So now I know two of the angles, 55 and 55, right? Plus that third angle, that vertex angle, which is the X, has to add to 180. Well, 55 and 55 is 110. And when I subtract 110 from both sides, I'm going to get that X equals 70 degrees. So that vertex angle is 70 degrees. Next page. Explore and apply the properties of exterior angles of a triangle. Now your picture looks a little bit different than what's in your notes because it also has angles 7, 8, and 9 are also exterior angles of the triangle here. So exterior, the sides of the triangles have been extended to form angles 4, 5, 6, and 7, 8, and 9. So they have 6. A triangle has 6 exterior angles. There's 2 of them at each vertex. So you can see 5, and then over here is the 8 at angle B. At angle C is 4 and 7, and at angle 1 is 6 and 9. The interior angles, angle 3 and the exterior angle 4 are adjacent angles, and they're on a straight line. So I know that they are also supplementary. You know that the sum of the measures of the interior angles of a triangle is 180. So 1, 2, and 3 have to add up to 180. You can use these two equations, that 3 and 4 also add to 180, to demonstrate a property about the exterior angles of a triangle. Well, the measure of 3 and 4 is 180, and the measure of 3 and 7 is also 180. The measure of angle 1, 2, and 3 is also 180. So I can substitute things in. If I know that 1 and 2 are 180, well, I can substitute them in for the angle 4. The exterior angle of a triangle is always supplementary to the interior angle of its that it is adjacent to. And it is always equal to the sum of the other 2 interior angles of the triangle. So the measures of angle 1 and 2 are equal to the measure of angle 4 or 7, the exterior. So the exterior angle is equal to the sum of the opposite 2 interior angles. That's what this is saying. And you can see that they are going to make equivalency. So you may want to pause the video and read this over and absorb this for a minute. Give yourself a chance to, just take this in another reading. Next page. Use exterior angle relationships to find angle measures. Find the value of the variable. So I can see that the exterior angle is the X. Well, the exterior, the remote exterior angle is what it's called because it's not next to the 50 and 60, is equal to the sum of the 2 remote interior angles. So 50 and 60 adds to 110, so X is 110 degrees. In letter B, I have part of an exterior angle plus a Y has to equal the sum of those remote interior angles, 45 and 30. So they add to 75. If I subtract 55 from both sides, you can see that Y must be 20 because this 55 and this 20 has to equal the measure, the sum of the measures of 45 and 30. So practicing that, this exterior angle in this triangle here is 132. So it is equal to the sum of the 2 remote interiors. It's equal to the sum of the 2 remote interiors. So if I subtract 62 from both sides, I get that that angle must be, this angle X, must be 70 degrees. I have an exterior angle, part of it, 35, but I have the two remote interiors. So again, this 35 plus some x has to equal the sum of the two remote interiors. Whoop, don't put degrees in that equation. 70 plus 41. So we get that 111, and if I subtract 35 from both sides, I'm going to get that x equals 76 degrees. Next page. Use the properties of interior and exterior angles of a triangle to find an unknown angle measure. Triangle PQR is an isosceles triangle. I know that because they're telling me, and it has these slash marks. Find the measures of angle 1 and 2. Well, I know that this exterior angle 1 to this 120 is the supplement. So 180 minus that 120, that exterior angle 1 has to be 60 degrees. So angle 1 equals 60 degrees. I know that. And angle 1 is the remote exterior to angle Q and R. Well, Q is the 2, so 60 has to equal angle 2, which I'll say Q plus R. And since it's isosceles, they have to be exactly the same. So 60 divided by 2 is going to give me that 30 is the measure at angle Q or angle 2. And it's also angle R here. So angle 2 is 30 degrees. Number 5, triangle ABC is an isosceles triangle. Find the measures of angle 1 and 2. Okay, it's isosceles, so I know this other base angle is 75. So 75 and that angle 2 must be supplements. So 180 minus that 75 gives me 105. So I know that angle 2 equals 105 degrees. Angle 1 has to be the sum of the two remote interiors, B and C there. So angle 1 has to be 75 plus 75, which is 150. Not too bad. And last question. Triangle EFG is an isosceles triangle, and EF is parallel to HI. Find the value of x. EF is parallel to HI. Oh, and there's a pair of vertical angles there, so that's got to be 30. These two angles have to be exactly the same. Oh, I've got a pair of vertical angles here. This angle and this angle are vertical angles. So this has got to be 30, which means this is 30 because of that being an isosceles triangle. 30 is 60. So 60 plus that x has to equal 180 because that's a triangle. So that x has to equal 120 degrees. Ooh, that took a little thinking there. And that's it for today's video.